Okay. So remember in, I guess in grammar school, middle school, and high school, you learned about the scientific method. You remember a hypothesis and you test it and there's a theory, and basically there is this outline of a process that you go through in doing scientific discovery. Well, the same exists in the engineering design process. And it's interesting, probably when you guys were in grammar school, the science fair in Santa Cruz was called the Santa Cruz County Science Fair, and that was all it was called. And then when I had younger kids and I started helping the my kids' classes get into the science fair, I was helping the science fair committee, and they actually changed the science fair from Santa Cruz County Science Fair to Santa Cruz County Science and Engineering Fair, which I was really excited about, because going through the engineering design process, it's similar in that there is a process like the scientific, why am I losing the word? The scientific method. And I was really happy that the county did acknowledge that going through an engineering design process is just as valuable as going through an engineering science, a science, why am I keep losing the word? The scientific method. The part I like about engineering is that there's this creative process involved, which I really love. So what I want to do now is I'm presenting you the engineering design process. So there are different stages. The first stage, and let me just have you read the first stage for a moment. And I can't see your faces, so I don't know if you're finished reading or not, but I'm just going to make the assumption. So a problem statement is a brief, concise statement, and I'm going to say that it's one sentence. So in this class, when we go through the engineering design process and you choose what the problem is, our statement is going to be only one statement. Okay? And like I said, we're going to work through this we looked at this Concordia ship already. We're going to look at the engineering design process, and then we're going to do one together. So a problem statement is one statement. It does not include all the information about the problem. It's just one statement. Stage 2, problem analysis, is where we learn all the details of a problem. Who it impacts, what the problem is, where does the problem exist, why is there a problem, when does the problem exist, how is it existing? And I'm sure that in your regular life, there probably have been times, maybe something in your house or your bike or something that you had was just not working properly, and you ran to the store and you bought something and you came back and you tried it out and it didn't work. And the reason why it didn't work is you did not completely analyze the problem first. You looked quickly at the problem, came up with a quick solution, went to the store, waste your time, waste some money, bought something, come back, and then you realize that solution doesn't work. Well, in engineering, we don't want to do that. We don't want to look quickly at a problem, come up with a solution, have to go back to the problem, go to the solution, go back to the problem, go back to a solution. What you really want to do in the engineering design process is thoroughly look at the problem before you start investigating the solution. Does that make sense, everyone?
Yep.
Thumbs up? So stage 1 is one short statement, and stage 2 includes all the details of the problem. So in this Concordia ship, the problem statement is a cruise ship is on the side. It's laying on its side. One quick statement. The cruise ship is laying on its side. The problem analysis would include a lot more. Where is it lying? What is the depth of the water? What is the quality of the water? What are the fish there? What kind of reefs are there? How big is the ship? What's the volume of it? How much oil is in it? Fuel is in it? How much everything? You would want to know all the details of the problem. Does that make sense? So now I'm going to stop for questions, and I'm going to stop sharing the screen so that I can see everybody's faces.
I have a question.
Yeah, who's talking?
Alex.
Okay, Alexander. Yeah.
So what if you just want to design a product? Is the lack of that product existing for your company considered the problem, or?
It depends. Like, for instance, I could give you an example. We had a student, Ian Stramitis, that worked for Giro. I don't know if you know, but Giro is in Santa Cruz County. They used to make bicycle helmets. They probably still do. They got
Okay.
bought out by a few companies, Bell Helmets, and now the company's called Vista, and they're in Scotts Valley. And when he was working for them, they wanted to enter in the realm of making bicycle lights, and they had never done that before. So they put Ian on the task of researching all the different bicycle lights out there. What are their pros and cons? Figure out what the problems are, and then start developing with a team of engineers this new product. So even in the case when you're trying to come up with a new product, you are looking at what the problem is, which may be that something doesn't exist. Like right now, what are scientists and engineers trying to do? We don't have a vaccine, right, for the coronavirus. We don't have enough masks and protective gear. So they're coming up with new products, but they're going to be doing some research, and that research would be part of the problem analysis.
Okay, so the
Yeah.
problem could just
Yeah.
be that this product isn't on the market for our company yet.
Yes, and find out if some companies do have that a market, maybe in this case bicycle lights, what is it that is not working with them? I mean, there have been situations, of where products have been invented accidentally, right? Like Velcro. It wasn't designed to be a fastener. Or Post-it notes. Actually, Post-it notes is a better example. Post-it notes they were working with some kind of adhesive, and they learned that they discovered this adhesive that would be cool to put on Post-it notes. So it was kind of a indirect creation. Does anybody have another question? Okay, so one important element, I'm going to go back to sharing the screen. And I could see that we're nearing break time from the faces. So an important part of the engineering design process is first to really look at what the problem is, what problem exists completely before you jump to solutions. So if somebody said, what are the most important parts of the engineering design process? One of the answers would be to fully analyze the problem before jumping to solution. Okay, stage 3 is the answer to, let's go to stage 3 now. Stage 3 is design specs or solution constraints. It's things that will limit your solution. For instance, a schedule. If you only have 2 weeks to do a product, to design something, if you have 2 weeks to do the whole design process, that is going to limit what kind of solution you could come up with. What kind of material do you have available? What kind of equipment do you have? Maybe you have band saws in your garage. That's something that's if you don't have anything, then it's going to limit your solution. How much staff do you have? What are the ergonomic requirements? How it works with people when people use it? What's safety, environmental issues? Aesthetically pleasing, money. How much money do you have available? All these things right here are examples of things that would limit your solution, and they're called stage 3. So stage 1, short sentence on what the problem is. Problem analysis, details on the problem. Stage 3, what are things that will limit your solution? And like I said, we're going to go through this process for 2 things today. So you're going to have 2 examples. Stage 4 is brainstorming, and we already talked about that, and we did it with the Concordia ship. Brainstorming is another really important part of the engineering design process, where you have people who are not constrained in offering solutions. You want people to give any crazy idea that they could think of with no judgment, because you want people to be open-minded. I have my son's girlfriend's dad is a manager at Google. He has a bachelor's, master's, and PhD in mechanical and material science, and he's a manager now. And those of you who took Engineering 5 know that managing is a one function of an engineer. He's a manager now, and he said that the environment at Google, if anybody ever puts down anyone's idea, they are fired. They are out the door. Because Google wants to create an atmosphere of people feeling comfortable giving their idea. Because the more creative, the better the products. And that doesn't just exist at Google. There's a company called IDEO, IDEO. It's national. The headquarters is in, I think it's in Menlo Park. They're an amazing design company. So when a company wants to design something, they usually, some companies hire IDEO, and they have the same environment in their company, that everyone needs to feel welcome to share ideas. Okay, then there's stage 5, and let's just read this. In this stage, you must narrow down your options to the one or more than one you will test. Discuss each option, rate them numerically on how well they solve the problem and meet your design specs. So again, we're going to go through this process with some of the examples. For idea selection, you could imagine, let's say brainstorming, you came up with 20 ideas. Well, those 20 ideas, you want to rate those ideas, and you're going to rate them on whether they solve the problem and do they meet the design specs. And we do that in a table, and I'll show you an example of a table. So in stage 5 is when you're looking at all the brainstorming ideas and you're rating them according to how well they meet the analysis and the design specs. And then after stage 5 is when you do implementation and you make a schedule, and then you evaluate it, which means testing it. And then you might go back many times to different stages. Okay, so I'm going to stop sharing for a moment. Okay, so I've just introduced you to the process of the engineering design process. Short one-sentence problem statement is stage 1. Stage 2, more details on the problem. Stage 3, come up with things that limit your solution. Stage 4, brainstorming. Stage 5, analyze or rate the different ideas. And then stage 6, you start implementation, and then after that, you do testing. We're going to go over this in more detail, but right now you should have a framework by which we're going to be doing engineering design. So what are some questions you have? Oh, Angel, I see your comment. What a great job environment. Yes, it is. Okay, any questions?
For the upcoming project?
No, we're not gonna, I'm just asking
Okay,
if you have
okay.
any questions about the process so far. Okay, I think this is a good time then to take a break. And it's 5 minutes to 4. Boy, Aaliyah and Maria and Omar and Yuritsi, sorry, I definitely took a lot more time than I had expected. So they're gonna start prepping their presentation for abroad, and why don't we take a 15-minute break? So let's come back